This presentation is brought to you by the North Dakotans for Energy Independence. It's a group comprised of the North Dakota Corn Growers, the North Dakota Ethanol Producers Association, Blue Flint, and also the American Lung Association. We've created the Run With It campaign to educate flex fuel vehicle owners as well as the auto industry. And we've brought Rich Krager here to deliver this education to you to be able to be comfortable talking about ethanol, higher level ethanol, and what that means for flex fuel vehicles.
Hello, my name is Rich Krieger, and I'm here to talk to you today about ethanol as a motor fuel. Before we begin, I want you to know that my qualifications to discuss this topic stem from my many years of experience as a vehicle technician and as a fuel retailer, going way back to a farm service station that I owned in Iowa back in the 70s when we first started selling gasohol and servicing those same vehicles. So I am an ASE certified master technician. I have been since 1978, and I'm also certified in advanced engine performance, alternative fuels, and diesels. And I don't have an axe to grind. I work for a community college in Wilson, North Carolina, and been invited up here today to discuss ethanol properties with you, and ethanol technology and transportation. Things we're going to talk about today include an understanding of the difference between renewable and fossil fuels. We're going to talk about ethanol itself, what its properties are. We're going to talk about how we make ethanol and how much is made in the USA. And then we're going to get into the engine and vehicle technology, and we're going to talk about the energy and emission aspects of ethanol as a motor fuel. A little bit about the fueling infrastructure. We'll talk about ethanol blending, which is a situation unique to the Midwest, the United States. The Renewable Fuel Standard and Reformulated Gasoline Program, both run by the EPA. And finally, we'll mention some safety aspects that need to be understood for everyone who's working with ethanol. So let's talk about understanding the difference between fossil fuels and renewable fuels. First of all, let's define fossil fuels. Fossil fuels are fuels that come from petroleum. And petroleum is decomposed plant and animal matter that's been locked in the earth since the time of the dinosaurs and beyond. Plants and living organisms that died, some of their remains were buried into pockets in the earth, and under heat and pressure and over the course of tens to hundreds of millions of years their remains have converted to long chains of carbon and hydrogen that we call hydrocarbons, and that's petroleum. These fuels come in different molecule lengths. We use gasoline, which we basically are chains of carbon from 7 to 8 carbons long. When we take that fuel from the earth and burn it in an internal combustion engine, we release that carbon back into the atmosphere. It had not been there previously. It had been removed a long time ago, and the natural balance that over millions of years has developed between the content of carbon in the atmosphere and carbon in the earth is artificially changed. Now, we need to understand that carbon itself does not cause global warming. Carbon itself is not a greenhouse gas. Carbon is an element, actually it's a solid. What causes the problem is carbon combined with oxygen in the form of CO2, carbon dioxide. Carbon dioxide is the greenhouse gas. I'm going to say that again. Carbon dioxide is the greenhouse gas, not carbon. Renewable fuels, on the other hand, are fuels that are made from plant and animal matter that has just recently been harvested, maybe this year, maybe the last. And the carbon that those plants contain was taken from the atmosphere. It was not locked in the earth. So we've removed a corn plant, as it grows through the process of photosynthesis, will remove carbon from the atmosphere, convert it to sugars. We will harvest those sugars, convert them to ethanol, burn them in our engine, and put the carbon back. It's a neutral carbon exchange, and that's why we call these fuels, ethanol and biodiesel, carbon neutral. So let's take two cars. They're identical. One car, I'm going to put a gallon of gasoline in it, and I'm going to drive it until it's gone. What came out the tailpipe of that car? Carbon dioxide and water. Now we'll take the second car, fill it with a gallon of ethanol, and drive it until it's gone. And what came out the tailpipe of the ethanol-fueled car? Carbon dioxide and water. The difference is where the carbon came from. In the case of gasoline, the carbon came from petroleum. The carbon was previously tied up, locked up in the earth. We've now put it back in the atmosphere where it doesn't belong. Whereas burning ethanol, we've taken carbon that was already in the atmosphere until just very recently and put it back in the atmosphere, and we've just done a neutral carbon exchange. So replacing gasoline with ethanol can reduce total greenhouse gas emissions from transportation because the energy source for ethanol is plants, and those plants have just existed within the last year or two, and we are not causing a net increase of carbon dioxide in the atmosphere. Actually, according to the National Renewable Energy Lab over in Golden, Colorado, using ethanol produced from corn can reduce greenhouse gas emissions on a full life cycle analysis for about 18% for 10% ethanol and up to 29% for 85% ethanol, or E85. So let's talk about what happens inside the combustion chamber of the engine when we actually burn fuel. Now, of course, what we're doing is we're combining a hydrocarbon or an alcohol with oxygen to produce heat, to convert the fuel to produce a heat energy release that's going to expand the gases in the combustion chamber. That's going to push the piston down, turn the crankshaft, and we do work from that. The vehicle goes down the road, the stereo works, the headlights come on. We get useful work from the combustion of that fuel. But what else happens in the combustion chamber? We're taking a carbon-hydrogen chain, we're ripping it apart, and we're recombining the carbons and the hydrogens in that fuel with oxygen and nitrogen in the air. So first of all, we produce carbon dioxide, and we produce a pretty good amount of it. About 14% of what comes out the tailpipe of an internal combustion engine is carbon dioxide, a carbon with two oxygens. We also get, in some cases, carbon monoxide. Carbon monoxide is a poison. It'll kill you. We don't like carbon monoxide. We have spent hundreds of millions of dollars to try to eliminate it from vehicle exhausts. And it is a product, what you need to understand about carbon monoxide is that it is a product of two conditions. First of all, it is a product of cold combustion. So we get it when we're running an engine cold after startup and during warm-up. And it is also a product of rich combustion, or combustion in an environment where there is not enough oxygen, what we call a rich mixture. We also get oxides of nitrogen. Oxides of nitrogen occur in conditions of high heat and pressure. And oxides of nitrogen are a very bad thing. Probably public enemy number one up at the EPA's hit list. The EPA is doing everything it can to bring NOx emissions in vehicles as close to zero as we can possibly get them. But what is NOx? Well, when things get hot enough in the combustion chamber, the nitrogen in the air, and that, by the way, air is about 78% nitrogen, the nitrogen will start to combine with free oxygen atoms that are in the combustion chamber in either NO, one nitrogen and one oxygen, or NO2, nitrogen dioxide. And when these go out the tailpipe and get into the atmosphere, both NOx compounds, they rise into the atmosphere. If it's a sunny day, they'll be acted upon by sunlight, and they will cause the formation of, first of all, ground level ozone, which is a serious health hazard, especially for young and old people. They will cause photochemical smog, and it will also cause, in the case we get some clouds and we get some moisture coming along, we will get acid rain. So obviously these are all bad things, and these are all things that the EPA wants to eliminate, that the American people want to eliminate, which is why we have the Clean Air Act. And so NOx is extremely undesirable, but we do produce NOx in the engine. Oxides of sulfur, pretty much been eliminated as a pollutant, and this is because in the last 5-6 years we've seen the elimination of sulfur from our fuels. This was done by government mandate, and the sulfur is being removed from the fuels at the refineries. Hydrocarbons. So what is a hydrocarbon? Hydrocarbons are simply fuels that you paid for, put in your tank, ran through your engine. They didn't burn in your engine, which means you wasted it, and basically you've thrown your money out into the street. So hydrocarbons in the exhaust system is fuel that you did not burn, you did not get any benefit from in the engine. And finally, there's particulate matter. And particulate matter is really mostly just solid carbon. It's that black soot we see coming out of especially older trucks. Particulate matter is really an issue for diesels. Gasoline engines do not produce significant amounts of it. Well, what's ethanol? Well, ethanol is alcohol. It's what you drink. It's been around for at least 9,000 years that we know of. Distillation from wine has been documented as far back as about 850 AD. Pure ethanol was produced in 1796 by a charcoal filtration method, similarly or later adopted by Jack Daniels and others. It's been used as a fuel for lighting since the 1840s, and it's been used as a fuel for automobiles since 1908. One of the interesting things about working in the alternative fuel business is that really, with the exception of possibly hydrogen, none of these technologies are really new. We've had electric vehicles since 1901. We've had biodiesel since 1890. We've had ethanol since 1908. We've had natural gas since World War I. So none of these are new technologies. It's just that they're getting better. So ethanol is a straight chain alcohol. Its molecular formula is 2 carbons, 5 hydrogens, and a hydroxyl group, or an OH, which is what makes it an alcohol. It is the oxygen in that fuel chain that gives ethanol its unique properties, both good and bad. And I'm going to explain to you both the good and the bad of this fuel. It's a 2-carbon fuel, which makes it heavy enough to be a liquid. But by weight, with that oxygen atom, 30% by weight is oxygen. And that produces many unique effects for this fuel. We denature it, which means we poison it with gasoline, with small amounts of gasoline, to make it undrinkable. This is, by law, this is done at the production plant, and it is required to do this so that we don't have people hijacking carloads of ethanol, bottling it, and selling it to their friends. So it's all poisoned with gasoline, which we call denatured alcohol. It mixes very easily with gasoline, so it's blendable. Mixes easily with water, which is a problem. Actually, we call ethanol a hydrophilic substance, which means it likes water. And if it can find water, it will absorb the water and hold it. And water and close tolerance fuel injection components do not get along very well. So keeping ethanol dry and free of water is an issue that has to be, technicians and fuel distributors have to be aware of. It's biodegradable. If I spill some gasoline on the ground, I'm going to have to call the hazmat people out, and they're going to have to remove the gasoline and the contaminated soil because it's a hazardous substance. We don't want it getting into the groundwater. It can cause long-term damage to aquifers. Ethanol, on the other hand, completely biodegradable. Ethanol, if pure ethanol were to spill from a tanker truck, for instance, we want to eliminate the immediate fire hazards, but beyond that, the ethanol will completely degrade by itself into completely non-toxic substances. It's carbon neutral, as we've already described, and it reduces the emissions of hydrocarbons and carbon monoxide. And I'm going to explain how that happens a little later. It contains 35% oxygen by weight, and that's why the EPA mandates its use, and I'll explain the technology of that also a little later. It has a high octane rating. It's an octane booster. And because it can raise the octane of gasoline, it allows us to do things to the engine that we can't do with a straight gasoline engine. Especially, we can run an engine with a higher compression ratio, and when we're using ethanol as a fuel, we can run a higher advance curve, which means basically we're uprating the engine. Now, do we make engines today that run at their peak efficiency? The answer is no, we don't. we have to actually severely detune our engines so that we can meet emission standards, especially for NOx. A high-performance engine with no other considerations but power and efficiency would make a great deal of NOx, more than we could tolerate, more than government regulations would allow. So automakers detune their engines, run really with lower compression ratios than are desirable, except for the compromises we have to make to meet emission standards. When we start using ethanol as a fuel, we're able to go back in the direction of performance and power without sacrificing emission levels. So we can uprate the engines again, we can tighten up or run tighter, better advanced curves, and we can go back to raising compression ratios again. And this is one of the big advantages of ethanol that the automakers are just starting to take real advantage of. The energy density of ethanol, and I'll explain that in the next slide, is less than gasoline or diesel fuel. And this is why, especially in some older flex fuel vehicles, we're going to see a decrease in fuel economy of somewhere between 10 and 20%. So what is ethanol? Where does it come from? Well, it's alcohol. It's what we call grain alcohol because it's produced by the fermentation of grains, of simple plant sugars made from grains. Typically in the United States we use corn, although we also use some sugar cane. We grind the corn kernels up into simple sugars. We put it in a vat. We heat it up a little bit to create a better growing environment for bacteria. And we introduce yeast bacteria to the sugars, and the yeast eat the sugars. They love them. As the yeast eat the sugars and the yeast population grows, the yeast excrete ethanol. So ethanol is really not directly derived from the corn plant. Ethanol is a byproduct of yeast living their little lives. It's mixed with gasoline in transportation in a number of different blends. We use a great deal of 10% ethanol, 90% gasoline, which we call E10. We're just starting to introduce 15% ethanol and 85% gasoline. And then we have flex fuel, which is 85% ethanol, 15% gasoline. And we also have the blends here in the Midwest. And the blends can be anything from E10 up through E85. And it's the blend pumps that allow us to put those variable blends into our vehicles. Any conventional vehicle can operate on 10% ethanol or E10. It's been around for decades. I have personal experience with it. And let me tell you that if an older vehicle running on E10 has a drivability problem, it's because it has a drivability problem. The ethanol may exaggerate the problem or bring it out more, but a well-maintained, good-running vehicle should be able to operate on E10 indistinguishable from gasoline. Vehicles that use anything up through E85 are called flex fuel vehicles or flexible fuel vehicles because of that ability. Now, over the last couple of hundred years, as we've developed our transportation infrastructure, we've arrived at certain optimum fuels that have worked for us in transportation. These fuels are a compromise between the amount of energy a fuel carries in terms of its weight and the amount of energy that a fuel carries in terms of its volume. The perfect fuel for an internal combustion engine is hydrogen, which is pure hydrogen with no carbon at all. The trouble is, it's also the lightest substance in the universe. And to capture and contain enough of it in a small enough volume to make it practical to carry on a vehicle chassis and have any kind of reasonable range has been a very difficult thing to overcome. As we start to add carbon to the fuel molecule, the fuels get heavier, and that means that they carry more density per unit of volume. And the fuels that we've arrived at that are an excellent combination of volumetric and weight density are gasoline and diesel. And you can see them on the chart here. The renewable fuel compromises that we've come up with, or the renewable fuel substitutes, are biodiesel and ethanol. And as you can see, they both have a little bit less energy density, both by weight and by volume. Not so much with biodiesel, it's actually within about 6% of diesel fuel. Ethanol, within about 20% of gasoline. So it's not it's not a perfect replacement fuel, but it's the best we've got, and it does have the advantage of being renewable. It takes the carbon equation off the table. The other substitutes for gasoline and diesel that are coming into the marketplace, liquid petroleum gas and methane, as you can see, are much further down on the chart in terms of volumetric density, which means that carrying enough of those fuels to still have a significant range, a convenient range, a range that the customer will accept, is much more difficult. And also, those are both fossil fuels. The only true renewables that are available to us today are biodiesel and ethanol. I had to put the lithium-ion battery on this chart also because you can see it just barely makes it onto the chart, and that's the best battery known to our science, and this is the challenge for electric vehicles. But that's a discussion for another day. Why should we use ethanol then? Well, first of all, it burns cleaner. It's going to reduce emissions of CO significantly, carbon monoxide. It's going to reduce the emissions of hydrocarbons substantially, and also the vehicles, because they are flexible, have the ability of operating on any range of fuels that are available, from straight gasoline all the way up to E85 and anything in between. So overall, using ethanol as a motor fuel and encouraging the public to buy ethanol-fueled vehicles, ethanol-capable vehicles, will result in the creation of jobs. It will increase and stabilize farm income, which is the mainstay of the Midwestern economy. It will decrease the dependence on foreign oil by replacing foreign oil as a fuel, and that's a good thing. It'll improve our air quality. It will de-stress our emission systems, and it will, as the technology is emerging and the automakers are now able to make additional improvements in ethanol technology, it will increase the fuel economy of our vehicles. A little bit about the food versus fuel controversy. What we're doing when we're producing corn to use as a fuel feedstock, the argument can be made that that's not the best use of our land for crop production, that if we're not sinking carbon into a forest, if we're cultivating land, that land, the stuff we grow on that land should be used for food. Diverting some of it into motor fuels is controversial in some corners. But the thing I think the thing that I want to point out here, what the data indicates, is that the use of corn and sugarcane for fuel production has not significantly increased the price of food. The price of food has increased because of the natural economic factors that would have occurred anyway without the diversion of some ethanol into motor fuel. And the price of ethanol in the motor fuel market will follow the price of gasoline and diesel. The price of food derived from ethanol or derived from ethanol feedstocks, such as corn and sugarcane, will follow the price of food, not tied to the fuel market. So the evidence indicates that food costs are driven by overall energy costs, the overall situation in the food market, not by the diversion of corn and other feedstocks into fuels. On the positive side, the diversion of corn into ethanol production for motor fuels, which has increased every year, has had some very positive effects. First of all, it has nearly doubled our corn yields since 1981, and it has also, most importantly, stabilized corn prices. And for the farmer, this has been a very important positive trend, and certainly made it much more likely that a farmer can afford to purchase a motor vehicle. A bushel of corn will produce about 3 gallons of ethanol. We are constantly further hybridizing corn to maximize its production of starches, to maximize its benefit to the yeast, which maximizes the output of ethanol from the fermentation process. And we are expecting ethanol yields to go from approximately 480 gallons per acre today to 574 gallons per acre by 2014. A very significant increase in ethanol output. And this is coming from the use of improved tilling methods, and hybridization. A little bit of history on ethanol. Henry Ford was a huge backer of ethanol. He believed it was the fuel of the future. And he designed his Model T to be ethanol capable. Henry Ford believed that a farmer should be able to buy a Model T and should be able to grow his own fuel. And to that end, he promoted the grain mills. As a matter of fact, he sold them through his dealer network. And you could buy, back then, you could buy a grain mill, process your own corn into meal, ferment it, produce your own ethanol, and fuel your Model T accordingly. His 1908 Ford Model T was the first ethanol-capable vehicle. And by the 1930s, ethanol was available in more than 2,000 service stations in the Midwest. Now, why were we putting ethanol in fuel in the 1930s? We didn't have any, we didn't have OPEC, we didn't have any fuel shortages. But gasoline back then was really bad stuff. It didn't really work very well, and engine speeds were limited to around 1,200 RPM because an engine couldn't go faster than that on the quality of gasoline available because of its octane rating. It would simply knock itself to death. So people figured out that ethanol was an octane enhancer, and by blending it into fuel or using it straight, the performance of engines was greatly improved and they could run at much higher RPMs. Now, the use of ethanol for that purpose kind of came to a screech and halt when this fellow right here, Charles Kettering, the guy who invented the self-starter, which was first used in the old Cadillacs, 1912, when Charles Kettering stumbled upon a substance called tetraethyl lead, which really performed the same qualities, the same anti-knock functions as ethanol, with the added advantage that the lead was a good lubricant for the top cylinder components and really extended the life of the valve train and extended the life of the engine. Also, tetraethyl lead was something that the oil companies liked, and so they had a lot to do with its replacement of ethanol. During World War II, of course, gasoline was rationed. Petroleum was diverted largely to the war effort, and so ethanol came roaring back during the war years as a replacement fuel, especially in the Midwest. And since the Arab oil embargo of 1973, ethanol in a 10% blend has been very popular as a gasoline substitute or what we call a fuel extender. So we've had 10% around pretty much since that time. And in 1988, Congress passed the Alternative Motor Fuels Act, which set up a series of incentives to encourage the automakers to build flex fuel vehicles. And as a result of that bill, we now have almost 11 million flex fuel vehicles on the road today. Now, what were the incentives? Well, by building flex fuel vehicles, everyone that, for instance, Ford Motor Company makes, they get a credit. And they're able to use that credit toward their corporate average fuel economy or CAFE standard. And this allows the automakers to build a larger number of pickup trucks, SUVs, the vehicles that they really make money on, and of course, if they made too many of these larger vehicles, they'd exceed their corporate average fuel economy and they'd have to pay huge fines to the EPA. But by presenting the credits for the number of flex fuel vehicles they build, they were able to offset those lower fuel economy numbers. They're able to offset those lower fuel economy numbers and stay within their CAFE standard. Now, of course, hybrids and electric vehicles produce the same kind of credit structure. Ethanol is a volatile substance, which means that it converts to a vapor state very readily at room temperature. And that's why volatile substances are substances that we can smell easily. Gasoline certainly also being one of those. But the volatility of ethanol is very temperature dependent. And unfortunately, ethanol becomes non-volatile, or in other words, it doesn't even enter a vapor state once it gets below about 55 degrees Fahrenheit. Now, does it ever get below 55 degrees Fahrenheit in Fargo, North Dakota? Well, I think it does. So we have to make some compromises here, and this is how I'm going to explain the use of E85 instead of the use of pure ethanol. By the way, the illustration there is the ethanol carburetor on the old 1908 Model T. You see, you have to understand that liquid fuel does not burn. Liquid fuel does not burn. If we introduce liquid fuel into the combustion chamber of an engine and it is not in a vapor state, it will not burn. The engine will not start. Well, if it's 40 degrees out and I have pure ethanol in my fuel tank, what's going to happen when that ethanol is injected into the combustion chamber? It's going to flood it. It's not going to start because there's no vapor there. We have to have some vapor to start the engine. How do we do that? Well, we mix the ethanol with 15% gasoline, and that's why E85 is 15% gasoline. There are two major reasons, and that's one of them. With 15% gasoline in the fuel mix, we will get enough vapor, fuel vapor, in the combustion chamber at low temperatures to burn and to get the engine started. An engine fueled with E100, therefore, would not start cold. So just as ethanol, pure ethanol, has low vapor pressure when it's cold, conversely, it has pretty high vapor pressure when it gets hot. So again, if we use straight ethanol as a motor fuel, we would run into some vapor locking problems when engines were running at high temperatures. So again, the solution is to blend it down to 15% gasoline, 85% ethanol, and that's reason number one why we do that. Also, flex fuel may be blended down to as little as 70% ethanol during cold weather months, again, just to increase the proportion of gasoline to make starting a little easier. The combustion of ethanol, as we've talked about, reduces several air quality pollutants, but on the other hand, ethanol tends to produce more aldehydes in the exhaust stream. Now, aldehydes are carcinogenic compounds, one of them being formaldehyde. They're known carcinogens. We don't want them in the atmosphere. So the car makers have reformulated the catalytic converters on flex fuel vehicles so that they specifically target the aldehydes and break them down into harmless substances. It's important, therefore, first of all, that the proper converter be installed on a flex fuel vehicle if it's replaced during service. And the high vapor pressure of ethanol blends, especially in hot weather, also stress the evaporative emission system, which includes the gas cap, by the way. So it's important that these systems be properly maintained. So vehicle maintenance is key. So we want vehicle owners and vehicle service personnel to understand that excellent vehicle maintenance is key to the proper operation of a flex fuel system. The catalytic converter, of course, is the device that takes the air quality of pollutants that we've been talking about and breaking them down into the harmless compounds of carbon dioxide, water, and nitrogen. And so catalytic performance is critical, and it's important that the catalyst be properly maintained, that cat efficiency codes be responded to when they occur. So ethanol should only be used as a fuel additive in late model fuel-injected engines that are certified as flex fuel vehicle capable, or legacy engines, older engines, if they're properly converted. Do you want to run an ethanol V8 with a carburetor? You can. The parts are available as long as it's done properly and with according to manufacturer and industry specifications. That can be done, and many people do it. As ethanol becomes more popular as a fuel and the number of fueling stations carrying ethanol increases, the possibility that an older car or a non-flex fuel vehicle car might get misfueled becomes more likely. So if I were to pull into a gas station with my 95 Crown Victoria and fill it up with E85 unknowingly, I'm going to have some drivability problems occurring within the next day or two, and up to and including my check engine light will probably come on. And the only cause of that would be the fact that we're running ethanol fuel in it in a vehicle that wasn't designed for it. So technicians need to be trained to list as one of their first diagnostic tests when they have an adaptive code or a drivability problem. We want to train our technicians to look for an improper fuel blend right away as the possible cause before we start spending a lot of time in diagnosis or even replacing parts that don't need to be replaced. Ethanol test kits that will very quickly test for the presence of ethanol in gasoline are now very commonplace, very inexpensive, and the test can be done in minutes. So highly recommending that service personnel especially in areas where there are a lot of ethanol fueling stations. A non-flex fuel vehicle comes in with a drivability problem. Very early on in the diagnostic process, we'll perform a fuel quality test just to check for the presence of ethanol. Flex fuel vehicles themselves, of course, they can run on anything up to E85. They can also operate on straight gasoline. There are almost 11 million of them on the road today. And the biggest change in a flex fuel vehicle is that its engine management system is specifically designed to be able to change the fuel delivery map, to be able to run at varying air-fuel ratios, because E85 runs at a different air-fuel ratio than straight gasoline. E40 runs at a different air-fuel ratio than either E85 or straight gasoline. So the engine management system has to be able to figure out what fuel it's running and then adapt to it. And only flex fuel vehicles have that capability. How do we know it's a flex fuel vehicle? Well, we can tell by the VIN. We all know how to decode VIN numbers because we're in that business. The 10th digit, of course, is the model year. The 8th digit is the engine type. And especially for Ford products, the 8th character will tell you whether it's flex fuel capable or not. Chrysler does not use their 8th digit for that purpose. If you've got a Chrysler, there are other ways to find whether it's flex fuel capable most easily by looking for the certification label under the hood or the flex fuel notice inside the gas filler flap. Now, since 2008, by federal law, all flex fuel vehicles will have a yellow flex fuel vehicle fuel cap as long as somebody hasn't replaced it with a non-yellow flex fuel vehicle fuel cap. So that's something we want to make sure we don't do. But they should also have an identification label inside the fuel door. Other than that, flex fuel vehicles are very similar to conventional vehicles. There are some modifications, and I'll go through those right now. First of all, flex fuel ethanol attacks nylon. So all nylon fuel system components in a flex fuel vehicle have been removed and have been replaced with other suitable compounds. Plastics have been removed. The plastic gas tank will be gone in a flex fuel vehicle. It will be replaced with stainless steel. Most of the fuel lines will be stainless steel. As I mentioned earlier, of course, the catalytic converter will have been of a modified design to deal with the specific emissions of ethanol. The engine will be in a later model vehicle, the kind that you'll be selling. The engines will typically have higher compression ratios to take advantage of ethanol, different cam profiles to take advantage of ethanol, and hardened valves, valve seats, guides, and rings to deal with one of the drawbacks of ethanol, and that is its low lubricity. And in conjunction with this, it's very important that flex fuel vehicle owners and service personnel be aware that we need to put API grade SM motor oil in a flex fuel vehicle. That's very important. And there's a link there to the API listings on your slide. Being an alcohol, ethanol is a dry fuel. It is not slippery. It does not lubricate. So we have to upgrade the quality, the hardness of the valves, guides, rings, and seats that are used in a flex fuel engine. Even so, we still need some lubricity. So I said earlier that there were two reasons for the use of 15% gasoline in flex fuel, 85% ethanol, 15% gasoline. And cold starting being reason number one. The lubricity issue is reason number two. Putting that 15% gasoline back in the fuel provides, that gasoline will provide enough top cylinder lubricity combined with the upgraded components will give the engine a normal operating service life. But again, only when used in conjunction with SM grade motor oils. The real heart of the flex fuel system, what makes it possible to use in our OBD2 age, is the use of a air-fuel ratio sensor. Now that looks like an oxygen sensor, but it isn't. It is what we call a wideband sensor or air-fuel ratio sensor, and it is capable of actually determining the air-fuel ratio of what's coming out of the engine. And with this information, the computer can modify the air-fuel ratio accordingly based on whatever blend of fuel is in the tank. And the way this works, when you fuel, let's say that you've been running on E10, and that's your engine management computer has adjusted your air-fuel ratio so that it runs at optimum performance at E10. You pull into a blend station and you add an E40 blend. What'll happen is as you put the fuel in the tank, the fuel level sensor will indicate an increase of fluid in the tank, and it will send that signal to the engine management computer. So now the engine management computer knows that you've added something to the tank, but it doesn't know what it is. But as you drive off, the computer will go into a watch-learn mode, and for about 20 minutes and 20 miles of driving, it will analyze the exhaust gases and will compute the new air-fuel ratio. It will then put that air-fuel ratio into its program, and I'm going to say center the window, center the adaptive window on that ratio. And that's going to keep the engine, again, running at optimal, and it's going to keep the check engine light from coming on and still allow the system to adapt for the normal things that happen in engine adaptation, vacuum leaks, a dribbling injector, all that kind of thing. Just as a conventional computer can adapt to it, now so can the flex fuel computer. Older vehicles that didn't have these kind of technologies, if you went from E10 to E85, you probably saw a 15 to 20% reduction in fuel economy. And of course, the automakers were afraid that someone might trade in a vehicle that got 300 miles to a tank and buy a flex fuel vehicle and found that it only went 250 miles to a tank. And so what many of the flex fuel vehicles have done is automakers have incorporated somewhat larger fuel tanks so that even though the mile per gallon number has gone down a little bit, the range per tank stays about the same. So the people that are used to filling on every Friday night or something like that could still do so. Ford Motor Company actually has just announced a new innovation for flex fuel, and it's really exciting. Ford is doing prototype testing now on a new generation of the EcoBoost V6 gasoline direct injection engine, which will first of all be flex fuel capable, and secondly will use an enhanced version of their direct injected technology to put a small pilot injection of ethanol into the combustion chamber just before the main injection of fuel. Now, what this is going to do, the pilot injection is going to cool the combustion chamber as it evaporates. It's going to change state, so it's going to suck up it's going to need latent heat. It's going to cool the combustion chamber, bring the temperatures down so that we can control the combustion of the main squirt of fuel, and that is going to allow Ford, with this technology, to take the EcoBoost up to about a 13-to-1 compression ratio and to run a higher advance curve. And as most of you know, the existing EcoBoost engine is already 25% more efficient than a baseline conventional engine, and Ford has announced that this new system using ethanol will add another 20% to that efficiency. So we're approaching with this system an almost 50% improvement in efficiency over a baseline conventional engine, which is really, really exciting, and it should be a huge boon for flex fuel as a motor fuel. There's still some problems to work out. This system may require actually a true dual fuel capability, where we would have to have two fuel tanks on the vehicle, one for the blended fuel and one for neat ethanol or pure ethanol for the pilot burn. But these things are still being worked out by Ford engineers. We should know something. We should see this engine in production probably by the 2014 model year. Ethanol storage, same basic storage technology and pumping technology as what we're used to with regular gasoline. However, because ethanol is hydrophilic and has such an affinity for water, we can't pipeline it. We can only pipelines are too wet. We can't get enough. We can't guarantee that we can get them dry enough that a shipment of ethanol wouldn't pick up additional water. So we have to transport ethanol either by rail car or by truck. The storage tanks and equipment must be resistant to alcohol, which means they must be EPA certified, probably UL certified, must meet your local codes and standards, just as conventional tanks must, and also should have the blue E85 Pentagon attached to all the dispensers. So the fuel should be tested every 1 to 2 months for electrical conductivity. I'll talk about that in a minute. Particulate content, which would be contamination in the fuel tank, rust particles, dirt, things like that. Hydrocarbon content, which is how much gasoline might have gotten mixed into the ethanol in the transport process. It's Reid vapor pressure, which is really the best way to determine what percentage of a sample is ethanol and what percentage is gasoline. But all this information is readily available in the Department of Energy's handbook for the handling, storing, and dispensing of E85, and that can be downloaded at no charge from the Department of Energy's EERE website, and I've posted a link to that on the slide. You notice the label here, minimum 70% ethanol E85, and that label simply reinforces what I said earlier. In cold weather, the blend stock may go down as low as 70% ethanol, again, just to facilitate easier starting in severe cold climates. Things that you want to be careful of, these are the materials that do not like to be around ethanol. Ethanol will attack zinc, brass, lead-based solder, aluminum, and tern-plated steel. Ethanol will attack natural rubber, PVC, cork, leather, polyurethane, polyamides, and methyl acrylates. For instance, it'll eat right through superglue. And so flex fuel vehicles obviously have eliminated all of these compounds in their fuel systems. An older fuel system that contains, for instance, natural rubber hoses, cork gaskets, could suffer damage if inadvertently fueled with a high ethanol blend. On the other hand, there have been no reported failures of any dispensing equipment suffering any problems from the use of ethanol. These are the new blend pumps that have just come out, from one from Gilbarco, one from Wayne Dresser. These pumps are fully UL certified and fully ethanol compliant. Safety concerns, well, just remember that ethanol is a pretty good insulator, electrical insulator, and that means that if we're moving it from one tank to another, or pumping it through a pipe, especially at a high velocity, it's going to generate a static electrical charge. And if the pipe or the tank is not grounded, there'll be a static buildup, and if you might touch it with the fuel hose, there'll be a spark, could possibly cause a fire. So it's very important that all ethanol storage tanks and transport piping be electrically grounded whenever ethanol is being transported. It's a very important point. Other safety concerns, it's a Class 1B flammable liquid, and anybody that might encounter an ethanol fire, and I would think that would include technicians, should be trained in fire suppression of alcohol fuels, because the firefighting techniques for alcohol are different than for conventional gasoline. If you've got some ethanol on fire and you put water on it, all that's going to happen is that the ethanol, while still burning, is going to float on top of the water and flow wherever the water's going, possibly down into a storm drain or something. So people who might encounter an ethanol fire should receive training in fire suppression for alcohol fuels. And in any event, if you're working with an ethanol fuel dispensing station, any questions about ethanol safety or ethanol installations, you should always consult with your local fire marshal if you have any questions. Also, there are some links shown here. NFPA, which generates all the safety codes, OSHA, and the Ethanol Response Organization are all really good information sources if you have any questions. What about the blend wall and other blends? Well, of course, the most common ethanol blend is E10, which is fully compatible with all gasoline vehicles. We have a law that was passed in 2007 called the Renewable Fuel Standard, which has mandated that the United States consume 36 billion gallons of ethanol by 2022. Now, here's the problem. Given the number of flex fuel vehicles on the road, given the number of flex fuel stations that can fuel them, given the number of vehicles on the road using E10, if we do the math on all of this, we find that we can only use about 14 billion gallons of ethanol a year, and that's the blend wall. So blending to 10% for conventional vehicles means that the maximum fuel that we can burn is about 14 billion gallons. So how do we get to 36? Well, we have to use more ethanol in our fuel, and one strategy is to blend, first of all, to E15 for conventional vehicles, and also to introduce the multiple blends. The EPA has just approved E15 as a fuel, but only in vehicles 2001 and newer. The interesting thing about this is that back in the days, back in the 70s, when we converted from leaded gasoline to unleaded gasoline, you might recall that the leaded pumps had a big nozzle and the unleaded pumps had a little nozzle. And we put that fuel tank restrictor thing in the fuel filler pipe on the vehicle so that you couldn't stick the leaded big nozzle into it. However, with E15 or with E85, the EPA is not going to have us do anything like that. So really the only thing to prevent a consumer from misfueling a vehicle at a station with an ethanol pump is their own knowledge and intelligence. So again, consumer education on this point is going to be very important to ensure the success of ethanol and to prevent misfueling events. That said, most studies indicate that E15 is fully compatible on any OBD2 certified engine, which would be 96 model year or newer. But again, to reiterate, it's only going to be legally used in 2001 and newer motor vehicles. Now in the Midwest, you're very fortunate to have the option of fuel blending. So in the Midwest, you've got blend pumps, something we don't have out on the East Coast. The University of North Dakota, working with the Minnesota Center for Automotive Research, did an extensive study on flex fuels and unblended vehicles to find the optimal ethanol blend level. And I like to call that the best bang for the buck fuel. What's the fuel that gave you the greatest range in terms of fuel economy versus its price per gallon. And the findings of this study, which I personally fully agree with, is that ethanol content is not a direct predictor of fuel economy. Driver behavior is, climate is, road type is, the number of electrical accessories on the vehicle can also be a factor, but primarily driver behavior. The study found that E20, E30 ethanol blends outperformed gasoline in fuel economy. My experience and people that I've been in communication with tell me that something more like E40 is the optimal blend, but these are something for the individual consumer to determine. Another finding was that standard non-flex fuel vehicles operated just as well on E10 blends as on straight gasoline. And I think that's a very important one to remember. And also that vehicle emissions for all blends fully met EPA emission requirements, and in fact, emissions were improved in the key areas of carbon monoxide, hydrocarbon, and NOx emissions. So as we talked about earlier, ethanol really helps reduce the amount of carbon monoxide and hydrocarbons that are emitted by vehicles. And carbon monoxide, as I said, is a function of a cold engine, and hydrocarbons is also a function of a cold engine. And both of these pollutants are normally converted to water and CO2 by the catalytic converter. Problem is the catalytic converter only works when it's hot. Catalytic converter has to be about 500 degrees before it can do anything. Other than below 500 degrees, it's just a brick. So when the engine is cold, the catalytic converter is cold, and we can't after-treat the emissions of carbon monoxide and unburned fuel, and it's going to go right out the tailpipe and into the atmosphere. A study done by Daimler found that 98% of the emissions of hydrocarbons and carbon monoxide occur during the first 15 minutes of the vehicle's drive cycle over the life of the vehicle. And this is because of this problem. So what could the EPA do to try to combat those high emissions during engine warm-up? Well, the answer is ethanol. By putting ethanol into the fuel at a 10% blend level, and that additional oxygen significantly reduces the amount of carbon monoxide and unburned fuel that goes out the tailpipe. That is why the EPA has mandated that in cold weather months, fuel must contain 10% ethanol as what we call an oxygenate, and that is the reformulated gasoline program. In North Dakota, there are over 40,000 flex fuel vehicles. In the United States, there are over 10 million flex fuel vehicles. All the U.S. automakers sell flex fuel vehicles at no additional cost to the purchaser, per their agreement with the federal government, and all have announced plans to significantly expand the production of flex fuel vehicles. So it's good for us, it's good for our economy, it displaces foreign oil, it lowers emissions, and it improves fuel economy. So what are the key points here? What are the takeaways that we want to walk out of this room with? Well, for those of you in sales, I think the important points are, first of all, that ethanol technology has come a long way just in the past 5 years. So the stories and experiences that people had back in the late 90s and in the early 2000s, they may have had some bad experiences with flex fuel, but that's because the technology at the time was not what it is today. You need to stress to your customers that purchasing a flex fuel vehicle will give them fuel choices. And remember that even though right now we're not having another global fuel crisis, we could have it again. And with a flex fuel vehicle, they have the option of using more and more higher blends of ethanol fuels and use less and less gasoline. And that may become very important to their pocketbook at some point in the future. Along with that, customers should be educated on proper operation of a flex fuel vehicle in terms of fueling. You don't want to add small amounts of fuel. You don't want to go into a gas station and buy $10 or $20 worth at a time. You should not fuel until you have less than half a tank. And when you do refuel, you should fill the tank completely and not just add a small amount of fuel. And this is because remember that the fuel tank sensor has to detect enough of a change in fuel tank level to tell the computer to go into that relearn mode and relearn the air-fuel mixture. And I think most of the problems that occur in flex fuel vehicles are a result of that problem. Technicians, a few things that you need to remember as you walk out of the room today. And that is that probably the biggest issues that you're going to see with ethanol in the service department are going to involve vehicles that are not flex fuel vehicles. You're going to see the problems that result from misfueling. So again, be mindful that a drivability problem and especially a lean adaptation code in a non-flex fuel vehicle could simply be the result of somebody fueling that vehicle with a high ethanol blend. So before you go looking for vacuum leaks, component failures such as a defective mass air sensor, do an ethanol check on fuel sample from that vehicle. Arrange with your parts department and your service management to make those kits available to you and check for the ethanol content in the gasoline in the vehicle. And you are going to find more and more, I think, that many of your drivability problems are caused simply by a misfueling of the vehicle. As far as the maintenance of a flex fuel vehicle is concerned, you're not going to run into too many additional problems. You will have a set of additional and advanced diagnostic trouble codes to guide you through those processes when they occur. Take advantage of that. But keep in mind that when replacing components on the vehicle, the components that you install must be flex fuel vehicle capable. You cannot substitute, for instance, a green stripe barrier fuel hose for a natural rubber one, even though the natural rubber one might save somebody some money. You cannot replace a wideband air-fuel ratio sensor with an oxygen sensor. That simply won't work. It'll thread into the hole. It may even plug into the connector, but it's not going to work. And most importantly, you cannot replace a catalytic converter on a flex fuel vehicle with a catalytic converter that is not certified for that vehicle. And finally, and most importantly, make sure that flex fuel vehicles are receiving API grade SM motor oil in their crankcase. And remember, ethanol technology, flex fuel vehicle technology has gotten a lot better, and it's gotten a lot better quickly. So the things that you might have seen in a 99 model year vehicle, those things have been fixed. Dirt contamination issues that might have occurred at a fueling station 5 years ago, those things have been fixed. So today, ethanol is a great fuel for especially in the Midwest, and it's going to provide lower emissions. It's going to provide better fuel economy. It's going to provide less carbon dioxide emissions, less greenhouse gas emissions, and it improves the local economy. Everybody in the Midwest will fare better economically with the widespread use of ethanol in flex fuel vehicles, and that includes you and your neighbors and your friends. So if you have a bad opinion of ethanol because of something you saw happen a couple of years ago in an older flex fuel vehicle, get over it. Those problems have been fixed. Well, I hope that you found our discussion today worthwhile. I hope that we've debunked some myths about ethanol. I hope that we've answered some questions you may have had about ethanol. Well, that concludes our talk today. I hope that we've answered some of your questions about ethanol and about flex fuel vehicle technology. I hope we've debunked some myths. I hope that we've made you more comfortable with ethanol as a vehicle fuel and with flex fuel technology as a vehicle type that you would want to sell and service to your friends and neighbors and to your own families. This presentation has been brought to you by the North Dakotans for Energy Independence, and any additional questions, comments, concern, or additional help that you might need can be obtained at their website. I want to thank you for the time. I know your time is valuable, and I appreciate your spending the time listening to me. And before leaving, I just do want to say how fortunate you are. This is coming from someone who lives in the South, how fortunate you are to live in an ethanol-rich state with the fuel choices that are available to you in your North Dakota fuel economy.